In this video, I will explain how to classify turning points using the second derivative. So one way of determining the nature of a stationary point is for us to consider the second derivative, the 2y by the x squared. In this case, we find an expression for the second derivative. If it turns out to give us a positive value when evaluated at the stationary point, then we conclude that it's a minimum. If it turns out to give us a negative result, then it's a maximum. However, we need to bear in mind that this approach might be inconclusive when the second derivative turns out to be 0. So let's look at an example. We've got y 6x minus x squared. We start by saying that the y dx is simply 6 minus 2x. We set it equal to 0. We get that 6 is 2x, which means that 3 is x. Substituting x is 3 into the expression for y gives me that y is 9. And therefore, I proceed in determining the nature. I do the 2y by the x squared, so I differentiate a second time, and I simply get a negative 2. This is less than 0. I need to show the comparison with 0, and therefore we conclude that the point 3,9 is a maximum point. This can also be confirmed by considering that this is an inverted parabola. It's like this, so it has to have a maximum point. In this example, we need to find and classify the turning point on the curve shown here. The first thing to do is write the expression for y in index form. So it's 4x plus x to the minus a half, which means that the y dx will simply be 4 minus a half x to the minus 3 over 2. I set it equal to 0, so 4 is a half x to the minus 3 over 2. So 8 is 1 over x to the 3 over 2. If I reciprocate both sides, I get 1 over 8 is x to the 3 over 2. So I will now raise 1 over 8 to the power of 2 over 3 to obtain the value of x. It turns out that x is a quarter, which means that y is 3. So I've got the coordinates of the point. Let's proceed in finding the second derivative, the 2y by the x squared. So we differentiate once more. It's minus a half times minus 3 over 2 times x to the minus 5 over 2, which simplifies to 3 over 4 x to the minus 5 over 2. I will evaluate the second derivative at x is equal to a quarter. It turns out to be 24. This is greater than 0, and therefore we conclude that the point a quarter, 3 is indeed a minimum. As a final example, I would like to show you something that leads to the second derivative test not being conclusive. So we've got the curve y is 27 minus 2x to the power of 4. My first derivative, the y dx, is simply minus 8x cubed. If I set it equal to 0, I get that x is 0 will make the derivative 0. When I substitute x is 0, I get that y is 27. So I will now proceed with the second derivative. The 2y by the x squared is simply minus 24x squared. So if I evaluate the 2y by the x squared at x is 0, we get a result of 0. So this means that the test is inconclusive, so we cannot decide whether it's a maximum or a minimum. In this case, we could use the tabular method, or we could also consider that 2x to the power of 4 is always non-negative. So the value of y will always be less than or equal to 27. This means that 0,27 is a maximum. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.